Hey everyone, ready to dive in. This time, we're tackling a big one, like really big. How do we get to artificial general intelligence for real? Not just sci-fi fantasies, but AGI that can actually keep up with us
It's
humans,
the million-dollar question,
at
right?
least. And luckily, we've got something special to guide us, a research paper that's like a who's who of AI experts.
14 of them, all heavy hitters in the field, came together to thrash out a shared vision for AGI. It's called Mapping the Landscape of Human-Level Artificial General Intelligence, published in AI Magazine, which, if you're not familiar, is a pretty big deal.
Oh, I believe it. With a title like that, sounds like they mean business. And they jump right into it, don't they? Like, before we build AGI, we got to know what we're aiming for. Defining it, that's step one.
Exactly, and it's way trickier than it sounds. We all have these ideas from movies, robots taking over, all that. But for researchers, it comes down to measurement. How do you even measure something as complex as intelligence?
No standardized test for robots, then?
Not quite, though they do use the example of Deep Blue, remember that? The chess-playing AI that caused such a stir.
Beat Kasparov, a world champion. That was huge.
Huge, yeah, but not AGI. It could win at chef, incredibly complex, but could it, say, make you a cup of coffee afterward?
Good point. So it's not just being amazing at one thing, it's that human thing, learning anything, adapting, coffee making included, apparently.
Precisely.
Yeah.
Flexibility across domains, that's the human level part. And that's why this paper's so cool. It's less about answers, more like, here's a roadmap.
Ooh, I like a good analogy. Roadmap. Tell me more.
So instead of just a finish line, picture a whole landscape. That's what they want us to see. They use these frameworks, Piaget, Vygotsky, child development.
Names ring a bell, but robot toddlers, is that where we're at?
Not exactly. Think of it like this, Piaget. He gave us those stages,
Yeah.
how kids go from like sensory stuff as babies to abstract thought when they're older.
Crawling before walking, that kind of thing.
Exactly. Now, Vygotsky's like the other layer on top of that. He
Wow.
was all about how social stuff, the tools we use, shape learning. So on this AGI roadmap, you've got Piaget, those milestones, on one side. But then Vygotsky's influences are running alongside it.
Okay, so it's not enough to just hit the highest level of smarts. You also got to go through all that messy learning and developing we humans do just by existing.
You got it. It's not just about the destination, it's the journey. And it gets even more interesting because they bring in more than just psychology. They're talking physiology.
Makes sense. Got to look at the only working model of general intelligence we've got, our own brains.
Right. Then there's mathematics, like can we make intelligence into equations? Imagine trying to write down the essence of a thought. Mind-blowing. And then, because we got to build this thing, they bring in information processing, the computer side of things. How do we make those big ideas into something a machine can actually, well, do?
So we've got this awesome roadmap, this landscape of AGI, but how do we see it in action? That's what I want to know.
And that's where it gets really cool. The paper proposes scenarios, kind of like testing grounds, to see how an AGI would actually perform.
Okay, hit me with it. What kind of scenarios are we talking?
Well, one I like is called general video game learning.
Video games. Sounds fun. So we're making AI to fight bosses and level up.
Kinda, but think about it. Most of us, we pick up a new game, new controls, new goals, but we figure it out. We adapt, we learn. That's what makes it a perfect test. Can an AI not just play one game well, but any game you throw at it?
I can see how that would be tough. It's not just reflexes, it's thinking ahead, solving puzzles, even being creative sometimes.
Exactly. And it gets to this deep idea, credit assignment. Can the AI know which of its actions led to winning or losing? We do it without thinking, but to program that, really hard.
No cheating by reading the game's code aloud. It's got to learn like we do. Okay, I'm hooked. What other scenarios?
Well, this one always makes me chuckle, the Wozniak test.
Wozniak, as in Steve Wozniak, Apple guy, building a revolutionary computer, is that the test?
Even better.
Yeah.
Far more ordinary. See, Wozniak, he was skeptical about AI being truly general. He said, build me a robot that can walk into any random house and make a cup of coffee.
Wait, seriously? That's it? Making coffee? Not very, I don't know, impressive sounding.
And that's the point. Think about it, that simple task. It needs so much. Finding the kitchen, new environment every time. Where's the coffee maker? Every house is different, right?
Yeah.
Then using a coffee maker you've never seen before, different buttons, settings.
Okay, yeah, starting to see the challenge here. Like that saying, common sense is the least common thing in AI, right?
Exactly. It's all the stuff we take for granted. Knowing where you are in space, recognizing objects, even social stuff. What if the robot have to ask for help finding something? Natural to us, but incredibly hard to program.
So we've got video games for adaptability, making coffee for common sense. What else?
Well, since we're talking about stuff humans just DO, there's also a preschool learning scenario.
Oh, wow. Robot classmates, tiny desks, the whole bit.
Not quite, though. I'd watch that reality show.
Yeah.
This one's about whether an AI can do the stuff little kids do that we don't even think about because it seems so basic. Social interaction, simple problem solving, learning language.
Which, when you break it down, is insanely complex.
Exactly. Little kids are learning machines. They soak up info, experiment, mess up, try again. To make a machine do that flexible, that adaptable, that's huge.
It really makes you appreciate how amazing human intelligence is. We've talked a lot about what this AGI needs to be able to do, but the paper gets into how, too, right? Like, it's not just passing the test, it's how you pass.
You're spot on. They've got a whole list of competencies, the skills and abilities under the hood that any real AGI needs. And it's not just the obvious stuff. You've got perception, memory, learning.
Basics,
Right,
right?
right. But it goes deeper. Social intelligence, creativity, even aesthetic appreciation.
Aesthetic appreciation. Wait, so the AI has to, like, appreciate a sunset? Art, that seems extra.
Yeah.
Isn't the goal to make it smart, not necessarily cultured?
That's a great point, and it gets to the heart of what makes this paper so interesting. It's saying if we're building something in our image, it can't just be a really good problem solver. It needs some of that stuff that makes us human, that sense of wonder, that appreciation for beauty. It's like if we're going to build something in our own image, it can't just be a really good problem solver. It needs some of that stuff that makes us human. That sense of wonder, that appreciation for beauty.
So it's not enough to just ace the Turing test. It's got to have good taste, too. That's a high bar.
Right. And that brings us back to that roadmap idea. It's not like a set of instructions. It's more like, let's start asking the right questions.
Which is huge, especially in a field like AI. Everything's changing so fast. And reading this paper, even though it came out a few years ago, it doesn't feel outdated at all.
Totally agree. Those challenges, those questions they're wrestling with, they're even more relevant now.
Right.
Like one big one they bring up, how do we make AI that doesn't just learn, but learns like we do? Humans, we're so good at it, picking up on social cues, figuring things out from context. AI still struggles with that.
We're like the learning champions of the planet, but we don't even know our own secret. No wonder it's tough to program.
Exactly. And that connects to another big one, motivation. Humans, we've got this drive to explore, to figure things out, to create. It's not just about rewards or punishments, which is how a lot of AI is designed now. So how do you build that into a machine?
It's like you can give an AI all the data in the world, all the processing power, but if it doesn't want to do something with it, what's the point?
Now you're getting into the really tough stuff. And that's another thing this paper does well. It bridges that gap between the technical and the, I don't know, the philosophical. Building AGI isn't just about code. It's about what it means to be intelligent, conscious even, maybe even human.
It's a bit of a mind bender when you think about it too long, and it makes you realize, we got to get this right.
No doubt.
Yeah.
And that's why this whole roadmap thing is so important. It's not just a tech doc. It's like a call to action, to collaborate, to think carefully, to agree on what we're even trying to do here.
To make sure that when we do get there, when we do have AGI, it's something good for everyone, not just, a cool tech demo.
Exactly. And to make sure that we're asking the right questions along the way. Because the journey is just as important as the destination.
Well said. And for everyone listening, we want to hear from you. All those scenarios we talked about, the games, the preschool, the Wozniak test. Which one do you think is the most important for AGI and why? Hit us up on social media. Let's keep the conversation going.
Absolutely, because the more perspectives we have on this, the better equipped we'll be to navigate the challenges ahead.
Couldn't agree more. Okay, ready for the next part of the roadmap. Let's dive into some of the specific competencies they say AGI needs to master.
Oh, this is where it gets really interesting. We're talking about things like social intelligence, creativity even. It's like we're talking about social intelligence, creativity, even moral reasoning. This paper doesn't shy away from the big stuff.
Moral reasoning. Now that's a whole other level. Are we talking about AI that can make ethical decisions? How do you even begin to program something like that?
Right. It's one of the most challenging and fascinating aspects of AGI research. Because morality, it's not just about following rules, is it? It's about understanding context, navigating complex emotions, empathizing with others.
It's about being human, basically, which, last time I checked, AI is not yet. But seriously, it makes you wonder, if we can crack the code of moral reasoning in AI, what are the implications? For society, for humanity, it's both exhilarating and a little bit, I don't know, intimidating.
Totally. And that's exactly why this roadmap is so important. It's not just about, okay, here's how to build the most powerful AI possible. It's about how do we build AGI responsibly? How do we make sure it aligns with our values, our goals as a species?
Because with great power comes great. Well, you know the rest. But it's true, isn't it? If you're talking about AI that can potentially surpass human intelligence, we need to make sure it's got a good moral compass.
Absolutely. And that's something we need to be thinking about now, not after the fact. It's like they say better safe than sorry, right?
Couldn't agree more. So, as we wrap up this incredible deep dive, what are your final thoughts? What's the one big takeaway you hope our listeners walk away with?
I think it's this. AGI isn't just a technological challenge, it's a human one. It's about understanding ourselves as much as it is about building something new. And that's what makes it so exciting, so full of potential.
Beautifully said. It's a journey we're all on together, and this roadmap is a pretty amazing guide. So, to everyone listening, thanks for joining us on this incredible exploration. Until next time, keep asking the big questions.